when we started LEAPFROG, we had two historical references to take from. One was the Apollo LLRV mission, and the other was the Air Force kinetic kill vehicles.
They're the future of aerospace engineering. A team of USC students is about to launch a project that they hope someday will actually reach the moon. KCAL 9's Cater Lee shows us.
It's one small step for man, one giant leap for mankind.
Now, 40 years later, USC engineering students are taking another step in space technology. For 2.5 years, they've been working on this low-cost, NASA-inspired prototype of a lunar lander. It's a project called the Lunar Entry and Approach Platform for Research on Ground, or LEAPFROG. In the next couple of weeks, they will take the first test flight.
Fly up, stand, come down. That's it.
Whether or not the lunar lander lifts off and hovers as it's designed, the team will consider the mission a success. This is the first student-built lunar lander prototype in the country. With the LEAPFROG program, USC is growing a new generation of aerospace engineers with enthusiasm reminiscent of the Apollo era.
I have been with LEAPFROG for since its conception, and at that time I was doing my MS in electrical engineering, and it was LEAPFROG that inspired me enough that I went for my PhD in Astro. For me, it has been an awesome experience. Not only learning more into the computing and electronics and avionics that I was working on, but also into systems engineering and many of the mechanical and computing aspects of it. It's one of those projects that is truly interdepartmental.
0.2 meter change.
I feel like there were several things that LEAPFROG taught me. I think it was great as a flight project because much of what I learned there translated over into real flight projects in my current role, working at NASA Johnson Space Center as an aerospace engineer. Also with flight projects, nothing ever works right the first time, and of course there's always Murphy's Law that things will go wrong if they can. So, you learn that practical thing in doing these types of projects. We also had a lot of innovation in this group, and that mainly had to do with the lack of funding that we had, or the lower budget that we had. One of my favorite things to mention was that we, instead of developing complicated landing pads for the vehicle, we ended up using Dixie paper bolts, and through drop tests and other tests we found that this was sufficient to work for us. And even though it wasn't reusable, it was a cheap way, and it got the work done. So unfortunately, sometimes due to our lower budget, it hampered some of the work that we did. For instance, a lot of the work focuses or uses the information from gyros and accelerometers that we have on the vehicle to be able to hold the attitude of the vehicle. And in having a lower budget, we were unable to purchase higher fidelity instrumentation, and through that, much of our work went working on workarounds to this. And so, we learned a lot through the process, but it would have been nicer to have higher fidelity instrumentation so that we could move forward with the project. But overall, it was just a wonderful project, and I think it's one of my favorite projects that I've ever been on through school. I really miss it.
It's off.
LEAPFROG was the best academic experience I've ever had. We were given a lot of room to be creative. Besides the budget, there was hardly any constraints. Some of the most rewarding things was coming up with a low-cost, effective design. Had the opportunity to apply things you learn in the classroom. Of course, learned tremendously about teamwork, and had opportunity to hold formal design reviews in front of industry professionals, tasks which I now do as part of my work. And most of all, it was a lot of fun.
I got both the legs. Okay.
Okay.
Well, why don't just this one, yeah.
Okay, this is good.
Dintana, dintana, dintana,